Okay, so we're going to look at this optimization question. So at 10 o'clock we have a car crossing point Q0. So this car here starts up here at Q0, which is 4 kilometres from this point down here. So it's travelling south. And at 10 a.m, so that's when time equals 0, another car is here. So we have a car starting here and a car starting here. And as we go along, they're driving, so R is driving east and Q is driving south. Okay, we know Q is driving south at 100 kilometers per hour. We know R is driving east at 40 kilometers per hour. Okay, my question is, at one point in time, so after 10 a.m, is the distance going to be minimum? Okay, because obviously at this point they're getting closer and closer together because this one isn't travelling as fast. Okay, but the point's going to come where it's a minimum, and then this one's going to continue and this one's going to get further away. Okay, so in a optimization question like this, what are we trying to do to start with? Math sentences. So we're trying to represent this as some sort of function. Okay, so what is the function that we're trying to minimize or maximize? The distance between. So we have to have some way of representing at a particular time how far these distances are. Okay, so how far, let's just start with R. If this is time equals 0, how do we find the distance that he is away from R0? We're not Pythagoras just yet. Let's just ignore the top part of it. We're talking about how far is R away from R0. Let's call that distance R. dr. So how far away is R from R0 at time t? What do we know about that car, R? Travelling at 40 kilometres an hour. So we know that speed equals distance over time. And we want distance, so we have to multiply speed by time. So dr is going to be his speed, which is 40, multiplied by his time. Okay, so we know this distance is 40t. Okay, what about Q? How do we know how far? Now Q is a little bit different. Q is getting closer and closer to this point. So what's this distance here going to be? How far away is Q from its initial point? So we'll call this dq. So dq is going to be 100t because he's going 100 kilometers per hour. Okay, so he or she, 100 kilometers per hour. And then how far away from, so this distance down here is going to be, this is going to be 4 minus dq, which is 4 minus 100t. The 4 is from the total distance. So we know that Q0 is 4 kilometres away from that point there. Now let's assume all our units are in kilometres and hours and kilometres per hour. Okay, because our speed. So these times, t are in hours. Okay, so if it's a matter of minutes, we're going to get a decimal, and that's fine. Okay, so now we want to have something that represents the relationship between, or that gives us, well, what are we trying to minimize here? Let's remind ourselves. Distance. So we're trying to minimize the distance between the cars. So which distance is that? This diagonal here, I've got it labelled with D. Okay, and how can we represent that D? D, yeah, D is, yep. dq squared plus dr, that's dq. Don't forget to square root it. Thank you, I was waiting for that. So this is Pythagoras, so it's d squared is equal this. Okay. Now let's put in our let's put our values in. So we know what dq is. dq is 100t.
Yeah.
So we've got 4 minus 100t, 4 kilometres here. Because that's, the 4 kilometres was given.
And then the DQ is
Okay, so I just want to wind up all these discussions. Okay, so we're all good with the 4. Okay, now over here, the distance, so we're using Pythagoras for the distance. So a squared plus b squared equals c squared. So a squared is this, b squared is this, and that's d squared. But we've square rooted it. Now this is our function for d. Now, is this something really easy and straightforward to differentiate? No, it's not. It's not, is it? Okay, so let's think about how we can simplify it. Well, yes, I'm actually going to take a different tactic. So I'm going to square it. And I'm actually going to go back to, if d is equal to that, then d squared. Well, yeah, I could have, but I didn't. Okay, so let's just expand this. This will be 6. I'll talk about while I'm doing this. Why I'll talk about this after. So is that take 400, take 800, 800t plus that's 10,000t squared plus 1600t squared. So that's 11600t squared, take 800t plus 16. So this is a function that gives me d squared. Now, when I have, remember these are numbers, okay? So that is probably a little bit obvious. But the reason I'm saying that is because if we've got d, so I'm trying to find a t that minimizes d. So just ignore this for a second. If I have a function where I have something that minimizes another number, okay? So, well, let's look at this. So we have some t is going to give us the smallest d, okay? As in, at some point in time, I'm going to get the smallest distance between here and here. If I square those values, so if I square my function, I'm going to get the smallest number that's going to give me d squared. Okay? So in other words, this is my d squared function. The same t that minimizes d is also going to minimize d squared. Okay, does that make sense? I'm seeing some nodding. Okay, so if I find the t that minimizes d squared, that's going to be the same t that minimizes d. Okay? So let's, to minimize it, we want to derive it. So d squared dash, so this is the derivative of d squared, is going to be, thank you, 200t, take 800. Okay? And we're going to let d squared dash equal 0. Why are we doing that? Find the stationary point. So we have 0 is equal to 23200t, take 800.
800 divided by 22,200. I'll tell you what that is.
What is that?
Also, you go to 0.
And I've gone off the page. So what do I get for that?
129.
129? Okay, so what is that unit though?
Hours.
That's hours. Okay. Now how do I check that that's a minimum? Double derive. It's probably a chair or something, or a desk. Okay. That got in the video, I think. So d squared double dash. Okay, we'll check the nature. So the double derivative is positive 23200, which is positive, so therefore my turning point is a min. So that means that this minimizes my function, okay, which means that the minimum distance is, well, it's going to be the square root of this, isn't it?
Put that back into the OG equation there.
Yep. I'm running out of room, but I'll just deal with it. 4, take 100 over 29 squared plus 40, 1 over 29, square that. Someone got an answer for me?
Why is that 100 over 29?
100 times 1 over 29.
Oh, fair.
Yep, I could put that as 40 over 29 too, but I didn't. And if someone's got an answer for me, well, the video's about to cut out, so I'm just going to end it there.